problem, and unfortunately I'm human and I didn't catch the error that was there. I knew it was there and I didn't catch it. Okay, so everybody, we're going to go through this one really quick. Given a sample space, I love you. I-L-O-V-E-Y-O-U. Notice, there's two O's in here, right?
Yeah.
Okay, just to notice, just besides the point. Then A is a subset, which just means a smaller piece of the sample space. So we pull down an L, we pull down an O, a V, and an E to make a subset, right?
Okay.
Now we put it back up there, make a different subset. We pull down a Y, and we pull down an O, and we pull down a U. Okay, so everybody keep in mind. Now this is where the error came in. First of all, we have two O's, but in the sample space, since it's not the alphabet, is it possible to have two O's? Well, yeah, we could put a duck and a cow in there if we wanted. So we can have two O's. This is O number 1, and this is O number 2, okay? I'm going to write that so that it can help us not make the error that we made. Does that make sense? They're two different O's. This is O number 1 and O number 2. All right, so let's go through and fill in our diagram. So this is event A, this is event B. So now let's go through and carefully place things where they need to go. So in A, we have an L. Do we have an L in B?
No.
So just in A. Now we took the L and floated it into the right spot. Now it's gone out of the sample space. Does everybody understand?
Yes.
Moving on. O, do we have an O?
Yeah.
Yeah, an O1, right? So let's just put O right there, O1. Okay, so I took care of one of the O's. Does that make sense, everybody? I don't cross out two of the O's. Just one.
Oh, I see.
Yes. So now, yeah, let's continue. V is in A, is it in B?
No.
Nope. E is in A, is it in B?
No.
Okay. So we just took care of an E. Now continuing, finishing off B, we have a Y and a U, right? Y and a U. So we took care of Y and U. So now let's look. What's left floating in the sample space? An I and an O, right?
Yes.
An I and an O.
That's so dumb. I realize.
Now guys, everybody listen up. This should hopefully help make sense. We've just taken these letters and placed them in our Venn diagram. So we should have the same number of letters in our sample space as in our Venn diagram. We're just putting it in the correct spot. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. There should be 8 in our Venn diagram. 1, 2, 3, 4, 5, 6, 7, 8. Does that make sense? So I messed up. I just royally screwed up on that.
Everyone failed that one.
Well, that problem, this is a more advanced probability problem because there's multiple O's, and that throws people at this level off quite a bit. I didn't think through that problem very good before I put it on the test, because it's higher than necessarily we need to know in this class, because you had to really think about that. So no, well, I'll make sure to make it, I'll get to another example. So just a second, and then I'll tell you what to expect on the test. How hard. Does that make sense? Yeah.
You crossed it out. I don't like when you figure out the first one, when you go to the second.
Well, because this O is a different subset than this O, right?
Oh, okay, so
that's why we really only use one of the O's. But let's do another one that will help you now Okay, so let's see something similar. Let's go to problem number 17 on the new practice. Everybody go to it. Hurry, hurry, hurry. Number 17 on the new practice. So the sample space is I love chocolate. Now notice, there's multiple O's. There's a lot of O's here. There's 2 E's. So there's multiple things here. There's 2 C's. But these C's are different because in the sample space, we were given multiple letters. It's in the sample space. If I would have said the alphabet, we'd only have one, right? But in the sample space, there's multiple C's. So it doesn't throw us off if we needed to. We could go through and say this is O1. O2 is different than O1 and O3. There's 3 O's available. Does that make sense? All right, and then there's a couple E's. So this is E1, E2. There's a couple C's, C1, C2. Now, like I said, this is pretty advanced for our level, and I didn't think about it because I've taught higher levels before, and I just put it on there. Yeah.
I thought you're not supposed to have more than one letter in that.
No, if it was the alphabet, we'd only have one to pull from, right?
Oh, okay.
But see, that's why this one's so much more complicated, is because kind of, just because we're not used to seeing it. There is multiple C's to use here, so it's okay to use them. Does that make sense?
Oh, okay.
So this would be using one of the C's, two of the C's. Does that make sense?
Yeah.
This is one of the O's, one of the O's, two of the O's. Does that make sense?
That's 3 O's.
These are different O's than these have nothing to do with these, right? You put them back in, so how many O's? 2. Okay, so let's go through this one and put these in the correct spot in our Venn diagram. A, let's call this event A, let's call this event B. So in event A, we have an L, right? Do we have an L in here?
Yeah.
Yes, okay, so we have an L in the intersection. We just took care of one of the L's, right? Was there only one L, one L? Yeah, they're not separate, they're the same L. That's why they're in the intersection. O, is there an O? Okay, so we took care of an O, it goes in the intersection. V, no, just in A. Took care of V. E,
Yes.
E and E. Okay, so we took care of one of the E's. Now continuing with B, we have a C and an H. A C and an H. A C2, another C, which is okay, right? So another C, because there's 2 available. Just like having a C1 and C2 are totally different. That's like having a heart and a cookie. Okay, O2, so we have an O and B, an A, a T, an E. That's it, right? We already had E crossed out. So now let's look at our sample space. What's floating? An I,
L,
an I, an O, an L, and an E. Let's count to make sure we've just taken these from our sample space and put them in here correctly. Well, I love chocolate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we're good. Does everybody understand that? Okay, so now do problems. Okay, so now if that was too hard for you to grasp, now you have the Venn diagram filled out, right?
Yeah.
We just went through it together. That's way more advanced than we need to be at this level. So I'm going to do one more example so that you're not thrown off. This is the hardness that you're going to see on the test. Are you ready to go through it?
Yeah.
Okay. So our sample space is H2LOVE3. Okay, so let's go through and fill in our Venn diagram. Now notice there's only one thing of each, right?
Yeah.
Okay, so let's fill it in. There now A and B are two different subsets. So A has an 8, does B have an 8? So it goes in A. We took care of 8. Is there a 2 in A? Yes, and in B.
Yeah.
So it goes in the intersection, right?
Yeah.
E, E. Yeah?
Yeah.
Obviously.
In the intersection. And then B has an LOV. LOV.
Then 3 is left.
LOV. Left is a 3 floating outside. Okay, so that's as hard as we need to be in this class.
Will we do probability after we do all
And then we could do probability, yeah. I'm just making sure we know, because probability after this and finding the union intersection is pretty easy for the most part. Okay, so now that we filled in this one together, everybody go through and answer those questions on number 17. Ready, set, go, quickly, so that we can move on.
Oh, crap.
Oh, by the way, okay, this is what is expected of you. So tomorrow, you have to have your first review finished. Also, you have to have your test number 1 completely finished, looked over, test corrections. That's going to be an assignment score. Then this practice that we get today, this practice, that whole packet, in order to retest tomorrow, you have to have it finished. So I would want it finished and correct, because why finish it and put in all the effort to just get them wrong? But you're not going to be able to completely finish it in class if you don't work really hard. Does that make sense? So I need you all to work, not even spend a half a second even blinking an eye at anything other than math. Okay? So today is the opportunity. Tomorrow is the only chance you have to retest, so you have to do well tomorrow. This is your retest, so you don't get a retest again. You need to do good tomorrow. Yeah.
What about tomorrow morning?
I'm not doing an early morning review. We've had so many review days that I feel like you should be ready by now.
So we have to have test corrections done too?
Yes. That's an assignment score. So if you didn't finish it, then you don't get full points on the assignment. But To be able to retest, you have to have these practice finished. And you need to have me here to check them, to make sure you're getting them right. So you need to work hard. Everybody go to problem number 5 and fix this. So it says the same thing. To make sure to ask you on the test both types. I'm going to say, flipping 2 coins, list the sample space. So that'd be, let's go with 2 coins right now. First coin, you'll land on a heads or a tails. Flipping your second coin, you'll get a heads or a tails. A heads or a tails. That's just your second coin, right?
Yeah.
Now let's say I said, okay, awesome. Now, what if you were flipping 3 coins? You just go out another one, right?
Yeah.
Heads or tails. Same thing here. Heads or tails.
That.
Okay.
Dude, that's like.
Okay. Continue. Everybody listen up. So number 2, it says if you flip the same 3 coins, so aren't these the same outcomes as above?
Yeah.
Okay? It says now, but the probability of landing on heads is 1 out of 3. So the probability of landing on heads is 1 out of 3. Well, the only other option is landing on what? A tails, right?
Which is 2.
So if 1 out of 3 times you land on heads, then how many out of 3 do you land on tails? 2 out of 3. Does everybody understand why that is?
Yeah.
Yes or no?
Yeah.
Everybody.
Yes.
Okay. So now it says, what's the probability of landing on a heads and a tails? So we know that happens right there, right there, right there, right there, right there, and right there, right? So now we need to know the probability of landing on a heads and a heads and a tails. Well, don't you find the probability of landing on a heads, then a heads, and a tails by multiplying the individual probabilities?
Yeah.
So it would be 1/3 times 1/3 times 2/3. Wouldn't the same thing be here?
Yeah.
1/3 times 2/3 times 1/3. Same, not same thing here. We would do the same idea though. 1/3 times 2/3 times 2/3. And then right here, it's the same thing as 2 heads and a tails, right?
Yeah.
So now I'm just going to find all of those individually. So if you do this, you're going to get 7.4. 7.4% chance here. There's a 7.4% chance here. And there's 14.8, I believe.
Wait.
You actually multiply it out and you'll get the same answer as me.
Is there any quicker way to do
And this is no, there's no quicker way. 14.8 and this is 14.8. So then I would add up those individual probabilities. So this is what I would have done. I would have found the 2 knots, which would have been here and here. That's only 2, right? I would have added those up and subtracted it from 100. That's way quicker.
Yeah.
But the reason I don't teach it like that is because then people are like, wait, I have no idea why you did that. I would have found the probability of landing on tails, 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 plus heads, 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 added those up, and then subtracted it from 100, because that's only 2 things to calculate. But that's just me. Does that make sense?
There's no quicker way.
Well, there's no quicker way than calculating the individual probabilities. If you can't think backwards, then you can't do it. Most people can't think backwards. If you understand why that works, then go for it. If not, then you have to do it this long way, which is fine. You might as well get it right. Okay, questions? Okay, so continue. You should at least read a problem number 4 by now. It's important. What if I said to you, the probability of landing on heads is, for example, let's say I said 2, 6. Well, what's the probability of landing on tails then? You tell me.
4, 6.
4 out of 6. Okay, but a lot of people really aren't getting it. So one more. If I said the probability of landing on tails is 2 out of 20, what's the probability of landing on heads?
18 out of 20.
18 out of 20.
How do you not get that?
A lot of people don't. I don't know. I'm trying to help them out. Okay, continue.
See how I'm trying.
Okay. 4.
Oh.
Why not? Where are you?
Where?
I'll just pick my hand on number 4.
Okay, so it says, describe the event that the summing of the 2 rolled dice is larger than 8 and even versus contrasting it with that the event is the sum is larger than 8 or even. Okay, so and and or, huge difference. And versus or. Well, first of all, to be able to do this problem, you would have had to set this up correctly. Is everybody good with setting one of these up?
Yeah.
Yes.
It's about this later.
What?
on it. So I was wondering about having it larger than 8. Can it be 8 or does it have to be 12?
So larger than 8 would consist of anything larger than 8, not including. Because 8 is not larger.
Even too.
But it has to be, so that's for and, right?
Yeah.
So larger than 8 and even would be, well, 10s and 12. So that happens 1, 2, 3, 4 out of how many times?
36.
4 out of 36. So what about or?
4
So if it's, so now read the difference on the next one. So it says larger than 8 would
would
be
be 9.
9s,
12.
10s, 11s, and 12s, or if it's even, it gets to come as well. So that would include all of these, right? Those are larger than 8, and or even. So now or evens are evens going to come. So 8s,
Oh.
aren't they even?
Yeah, 6.
Okay, 6s,
4s.
4s, and the 2. Count up that total over total. More than 18. No, more than 20.
Alright.
24 out of 36. Now on the test, you need to also write, if you want to get full points, the and is the intersection, which makes sense. It was picky. They had to be larger than 8 and at the same time even. Or is the union. So if it's either or, it gets to come.
Is it 20? Oh.
You have to write intersection on text, right?
Yep, and the probabilities of each.
Yeah, but my question was going to be if you could use 5 plus 5 to get 10 and use that, you know.
Okay, so number 7. What's the probability that the sum of the 2 dice will be greater than 8, given that the first dice is a 4? So we're talking after the first dice is a 4, right? So isn't that this row?
Yeah.
We rolled a 4 on that first dice. Now the second dice, we're either going to get a 5, depending on if we got a 1, a 2, a 3, a 4, a 5, a 6. Okay, so we're already rolled. Dice number 1. How many possible outcomes since that event's already taken place?
Okay, I remember.
So now what's the chances of getting a sum greater than 8?
2.
2 out of,
36.
nope,
2 out of 6.
2 out of 6. Yes, good. Because this is the given. 2 out of 6.
So it'll be 33%.
Because right here that happens, and right here that happens, so that's 2 out of 1, 2, 3, 4, 5, and 6. Listen. So number 9 says, everybody listen, you decide to tell your fortune by drawing 2 cards from a standard deck of 52 cards without replacement. What's the probability of drawing first an ace, then a jack? Well, first of all, you have to know your decks of cards. So we have hearts, diamonds, spades, and clovers. Right? Okay? And then we have ace through king, ace through king, ace through king, ace through king. Okay, so there's 13 cards in each suit. Okay, which, I mean, we already were given the total. Okay, so what's the probability of drawing first an ace? Okay, so we're talking first an ace. Well, how many aces are in the deck?
4.
So there's a chance 4 out of 52 on the first one. That does not mean we're drawing 4. That's the chances of drawing an ace. 4 out of 52. That's just one draw. Now we're not replacing the card, right? Did it say that? Without replacement. So now we took out an ace. So an ace is gone, so we're down to how many cards?
51.
So now it's a total of 51. Well, what's the probability of drawing a jack now? There's 4 jacks, so there's a 4 out of 51 chance of drawing a jack. It's that simple. You'll multiply them, right? The probability of event A, the probability of event B given that A has taken place. We multiply those probabilities. You should get 0.603%.
So it'll be 0.6.
Okay? Now I want you guys to practice 10 through 15. Ready, set, go. 10 through 15. I want you practicing those. Don't skip back to the front. Go. 10 through 15.
I have a question.
Try it. Okay, then. Okay, so it says, really, these are some of the easiest ones. You just got to know what you're doing. So it says, in a shipment has 20 computers, 6 are defective. 3 computers are randomly selected and tested. What's the probability all 3 are defective if the first and second ones are not replaced? Okay, so if you had to, couldn't we draw out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20?
Yeah.
Hello? Are you all listening?
Yes. Yes.
Okay, and then how many are defective?
6.
6.
1, 2, 3, 4, 5, 6 of them are defective. Does everybody understand that? Okay, so on the first one, we're drawing 1, 2, 3, right? Okay, on the first draw, what's our chances of drawing a defective?
1 out of
Nope, there's a lot more than 1.
6.
There's a 6 out of 20 chance. Now, once again, that doesn't mean we're drawing 6 out. That means there's a 6 out of 20 chance we drew a defective. Okay, now what's the probability it says that all 3 are defective on the first draws? Now, what's the probability of drawing a defective?
5 out of 19.
Good, 5 out of 19. Okay, well, that's just the chances. And now what's the probability of drawing a defective? 4 out of 18. Is everybody good with that?
Oh, alright.
Okay. Yeah.